We've known a lot about how birds migrate and the fact that ducks will spend their winters in the mid-continent region and in the south and in the Midwest, and then they'll go north to Canada for their breeding. But we haven't been able to track individual birds over time. With the new technology that's out, we can attach satellite transmitters to these birds and actually see where individual birds go across time. These new transmitters are solar powered, and then they transmit a GPS location to satellites 4 or 5 times a day, and then it's basically emailed to your computers. We couldn't study how individual birds made choices given a certain landscape, so the type of data that we're getting are very different, and we really don't understand migration very well with many bird species at all. Projects like this that are really helping us understand how far birds are moving and when birds are moving and how they're making those choices.
We used mallards for this study. Mallards are the most common and also the most harvested species in North America. They will go as far south as Arkansas, Louisiana. Mallards have been observed there, but we didn't know that individual birds were making these larger scale movements. But for the transmitted birds, we had several birds that would use the confluence area, so where the Missouri meets the Mississippi, kind of near St. Louis. And then we had a few other birds that stuck to a few refuges. One surprising finding of the study was how much they are using private lands, especially those that have been enrolled in conservation easement programs. And so they're using those much more than we expected and much more than you would expect just based on chance. Both public refuges and private wetlands to meet their annual life cycle needs.
It's really been a phenomenal investment in conservation, and it's nice to see that the birds are actually using that. Now that we understand how these birds move and what they use when they move, we're developing literally computer representations of birds so that we can test future conservation scenarios under landscapes that have more or less development, more or less agriculture, climate change. We want to present those sorts of scenarios to the model birds in the computer. It's kind of that thing that all biologists want to know. We want to get much closer to what the animals do, and the technology is letting us do that now.